Hello, EL Physics students. It is Mr. Thrasher. Welcome to our next video. We are still doing this online learning. We are going to talk about why the sky is blue and why sunsets are red. That's our physics objective. I know why the sky is blue and why sunsets are red. Last week, you should have done a reading that talked about this. This video is going to go over similar physics. I want to make sure we all understand why the sky is blue and sunsets are red. It's a difficult reading. First, I have a what do you think? Okay, again, Mr. Thrasher recommends you write it down, practice writing, but you're going to type in your answer as well. Here's what it says. Some people see this dress. Look right here. I have a dress. This is a picture. Maybe you've seen this before. This was really popular on the internet a few years ago. So we have this picture. It says some people see this dress as the colors white and gold. Some people see the colors black and blue. What colors do you see? When you look at this dress, what colors do you see? What two? What do you think? Put down your guess. I see the colors white and gold, or I see the colors black and blue, or maybe you see different colors. Write down your guess or what you see. Mr. Thrasher always sees white and gold. And that is different from a lot of people. About half of people think white and gold, and about half think blue and black. Sometimes colors can be a little confusing because color happens in your brain. Your brain decides color. Remember when we were mixing light, red and blue, that online simulator with the flashlights of light? Your brain combines color, and sometimes people's brains combine colors differently. Both are correct, but it depends on your brain. It's very interesting, I think. Okay, in order to understand why the sky is blue and sunsets are red, we are adding on to our words. Before we learned reflect, and we learned absorb. So we already learned those words. Reflect is bouncing off. Absorb is holding on. We're going to learn a new word today. Now we learned a little bit that like red light reflects off the apple, the other colors absorb. But our new word for today is scatter. Scatter. Try saying that out loud, even if you're in your bedroom or something. Try saying scatter. And this was in the reading. Scatter means to move in many different directions. And you move in different directions because it's like you are bouncing over and over again. So if Mr. Thrasher is going in a straight line, no scattering. But if Mr. Thrasher is walking and bang, boom, bop, ha, shoosh, bang, kablow, shoosh, I am scattering. This is an example. Maybe these are little balls or little particles. Here comes something, it goes bang, boom, plop, pow. They are scattering. They're bouncing over and over in many different directions. So that is a different thing light can do. Light can reflect, light can absorb, and light can scatter. Those are three things light can do. And here is a fact about light. Smaller light, smaller wavelength does more scattering. It's like opposites. If you have small light, small wavelength, big Scattering, it's a little difficult. If you have big light, big wavelengths, very little scattering, very little, straight line, constant. Okay, so if we look at our types of light, remember we learned red, orange, yellow, green. They are different colors because they have different sizes. Red light is the biggest wavelength. Well, big wavelength does not scatter. Red, constant, doesn't scatter. But as you go smaller, 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 the smaller the wavelength, the more scattering. Oh, look at this. Blue light scatters a lot, a lot. Blue light goes pow, bang, poo, pow, shush. It scatters a lot. Oh, a little difficult. Okay. So scatter. Big light does not scatter, constant. Small light like blue scatters a lot. Ah, here's my fun animation. Here is Stewie. Stewie is like blue light, and blue light scatters. Scatter, 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 scatter. Ah, here, Peter. Peter is like red light. Bigger wavelength, it is constant, not scattering. So blue light scatters a lot. Red light does not. It is constant. Okay. Other thing we need to know. If we look at the air, okay, look outside, look at the air. You can breathe in air. We can't see it, but air is made up of little particles. Have you heard of oxygen? And maybe nitrogen, carbon dioxide. Those are little particles. So it's difficult. We can't see them, but light is made up of particles. And particles is what can make light scatter. See, look, particle, particle, particle. La misma, it's the same. Particle, particle, particle. So the air can cause light to scatter because the air is made of little particles. Okay. All right. Now let's get to it. Let's understand why the sky is blue. Sorry, my eyeball's a little cut off, but right here's an eyeball. An eyeball is going like this. Here is the sun. Remember, the sun shines all the colors, red, orange, yellow, green, blue, violet. It shines all the colors. Here are all the colors. But it's shining through outer space, and then it gets to the earth. Well, the earth has atmosphere. That's a fancy word for air. This here is air. So I have air. Remember, right here, air, la misma, same thing. So when light gets to the earth, when it gets to the air is made of particles. And remember, small light, small wavelength scatters more. Big wavelength does not scatter. So let's look at red. Here is red light from the sun. Is red light going to scatter or is it going to be constant? Red light is constant. So it goes constant, 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 constant. Excuse me, constant, constant. Ooh, in your eye. Orange light is also pretty big. So it is constant. Yellow light is also pretty big. Constant. Oh, but let's look now at like blue. Now, what did we say? Is blue light gonna be constant or does blue light scatter? What do you think? We saw that blue light, it's small. Blue light scatters. So when blue light comes in, not constant, it goes boom. Then maybe bang. Then push. Scorch. Kapow. Bang. Whop. the blue light bounces. It bounces in the air. Push, 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 push. Over here, the blue light is scattering. So is the blue light going to your eyes? Oh, look at this. Not really. The blue light is over here and over here. So the blue light, this is important. So Mr. Thrasher has it in English and Spanish. The blue light scatters in the air and does not go in your eye. I have it in English and in Spanish. Similar picture. Similar picture. So here's the light from the sun. Here's the air. When the light gets to the air, red light, constant. Orange, constant. So you see it. You see reds and orange and yellow. But blue light and purple light and green light starts scattering. If you're here and you're looking toward the sun, look what you see. Red, orange, yellow. This is why the sun looks yellow. But if you look over there, not where the sun is, if you look over there, there's no red or yellow, but there's blue light. Oh, look at this one. Blue light enters your eye. This is why the sky is blue. Red, orange, yellow go straight into your eyes. So the sun looks yellow. But the sky, if you look over here, the sky looks more blue because the blue light bounces around a lot. Oh, okay. That's why the sky is blue. Interesting. Well, let's learn one more thing in this video. Why are sunsets red? When the sun is going down. Oh, it's so pretty. Okay, you see red and orange, sometimes pink. Why are sunsets red? It's the same kind of physics. More light will scatter if it moves through more air particles. So this is a little new. It's still about scattering light. So we know that blue light scatters, but also more air, more particles, more scattering. Okay, well, again, we need to remember red light does not scatter. Orange light does not scatter. But blue light, these colors scatter a lot. Okay, well, when the sun is setting, it is low, it is down. The sun is not up here, the sun is way over here. Well, think about it. When the sun was right here, it had to go through the light, had to go through this much air, this amount of particles. But now, oh my gosh, look at this. You have to go through a lot more air. Mr. Thrasher, you have to go through a lot more air. So, okay, if you have to go through a lot more air, here's another picture. Okay, when you're right here looking up, this is noon, when it's daytime, when the sun is above. But when it's sunset, you're going through more air. If you're going through more air, more particles, more light is going to scatter. Okay, so now with more air, the blue light scatters. But now even the green light scatters. Now even the yellow light scatters. The only colors that don't scatter, that are constant, it's going to be like red and orange. So you see red and orange because those are the colors of light that do not scatter. So they go all the way into your eyes. Again, lots of air, lots of particles, lots of scattering. Blue and purple scatters quickly. Green scatters a little later. Yellow scatters a little later. Orange and red, oh, they make it all the way through. So you see with your eyes orange and red. So again, I want the notes in 2 languages because this is a little difficult and important. Sunsets are red because more light scatters in the air. Only red and yellow light makes it to your eyes, and red and yellow light makes it a red sunset. Mr. Thrasher wants to demonstrate this with our simulator. Now, this is like the sun. The sun emits red, orange, yellow, green, blue, purple. Now, this only has red, green, and blue, so it's not exactly like the sun. Oh well, excuse me. But we can still use this. Remember, you see white when you see all the colors. When the sky is blue or when it's daytime, okay, and you look up toward the sun. Remember, when you look up toward the sun, daytime, well, red light goes to your eyes, green light goes to your eyes. Does the blue light go constant to your eyes, the blue light? No, the blue light scatters. So you have less blue light entering your eyes. So when you look at the sun during the daytime, what color do you see? You see the sun as yellow because some of the blue light is less because it's scattering around. And then kind of like the opposite. If you look toward the sky, you're seeing mostly blue. Maybe a little bit of green, maybe a little bit, but mostly blue. Oh, so here's the blue sky. Now let's think about sunsets. Remember, sunsets. Here is the sun. The sun during a sunset is low. It is low down. So there's a lot of scattering. No blue light. The blue light scatters. But also, there's so many particles, even the green light mostly scatters. So what color light gets to your eyes? Oh, mostly red. That's why our sunsets are mostly red. Ah, very interesting. The sky is blue and sunsets are red because light scatters. It bounces around in the air. Difficult topic, but I think that's very interesting. That's the end of my video. Thank you for watching.